Welcome back, and today we are going to see about the linear induction motor. So in previous section we are discussed about the induction motor, that is induction machine. It may be act as a motor as well as generator, so according to the speed variations. Then what is linear induction motor? So here in a linear induction motor, it is a special type of induction motor. So that means it is a modified version of an induction machine. So in conventional induction machine, it will rotate in the rotational motion. But the linear induction motor, it will travel in the linear motion. So that is rotational motion. This is linear motion. So that is the main difference between the ordinary induction motor and the linear induction motor. So it is a special type. Okay. So how it is designed? So here, so when we compare to the ordinary three-phase induction motor, the construction and operation, everything is similar, but the appearance is not about the conventional induction machine. So here, which is similar to the conventional induction machine, it has the stator as well as rotor. But here the stator is called as primary and the rotor is called as secondary, which is similar to the transformer operations. So here we are having the cylindrical stator. So the cylindrical stator, here we are cut it out, and so here the cylindrical part it will be cut it and it will be taken into the flat surface. It will be a cylindrical while we are cutting. So then we will make it into the flat surface. So this flat surface is called primary. In similar way, there will be a rotating part. It is also in the cylindrical form. That rotor it will be cutted and it will be make into the flat one. So that this is called secondary of the system. So the another variant will be called double-sided linear induction motor. So if you are having the one stator and one rotor, so we will get one primary and one secondary. So this is called single-sided linear induction motor. If you are having the two primary, that is in both the side of the secondary, that is called a double-sided. This is called a secondary. In upper we are having one primary and lower also we are having one primary. So there are two primary. So this is called double-sided with respect to the secondary. So this is the construction. So here there are two types. One is called a single-sided linear induction motor and another one is double-sided linear induction motor. Okay, so now you can see, so this is nothing but a stator and the inner part is nothing but a rotor. Inner part is nothing but a rotor and this is nothing but stator. So here the stator will be cutted and we are making into the flat surface, and the rotor is also cutted, we are making into the flat surface. So here we are having the one primary and one secondary, but here we are having the two primary and one secondary. So this is called a double-sided induction motor. Okay. So here you can see here, which is here we are giving the balanced three-phase power supply to the primary. So the primary consists of R phase winding, Y phase winding, B phase winding. Again R phase, Y phase, B phase. Again R phase, Y phase, B phase. So it will be continued. It is just like a rotational. But it is not rotational. It is a linear motion. So when we are supplying the current to this primary winding, the primary winding is getting energization and it produces flux which is similar to the rotating magnetic field. But it is not in rotational. It is a linear motional. Once we can start here and it will be ended here. Again it will be started here and it will be ended here. So like that it will change the excitation of the primary coils. Okay. So the produced magnetic flux from the primary that will be interacted with the secondary. So there will be an current, there will be an eddy current, there will be a current which is induced in this secondary. So that induced current, it interact the fluxes which is produced by the primary coil. So there is a tendency, it creates some magnetic force. So based on that, the secondary is also traveling along the primary winding, the excitation of primary winding. So based on that flux, it will be also gets traveling. So this is the, and here we are having in single sided we are having only one primary, and in double sided we are having the two secondary. So that is two primary and one secondary. So it is just like the in conventional induction motor. There we are having here the producer flux, which is equivalent to the rotating magnetic field. Okay, it will be excited by the balanced three-phase supply. So the velocity, the speed, the speed is rotational, but here the velocity is nothing but in linear motion. So 2t into fs. So the t is nothing but the distance between the pole to pole. The distance between the pole to pole, and fs is nothing but supply frequency. So based on the supply frequency and the distance between the pole, we can able to determine the velocity of this velocity. And so these are the few applications of the linear induction motor. So it can be used in the automatic sliding door, in electric train walls or some other places, and in order to handle the mechanical equipment such as train of tubes along a certain route, and metallic conveyor belt, pumping of liquid metal, then material handling in cranes, etc. So there we can use this LIM, and this is the main drawback. So it requires large air gap as compared to the conventional rotational induction motor, and the magnetizing current drawn is very high compared to the previous one, and the efficiency and power factor which is very less when compared to the conventional rotational induction machine. So this is an assessment. The frame of an induction motor is made up of either aluminium, silicon steel or cast iron, or it may be stainless steel. So put your answer in the comment section, and these are the few references. Thank you.